Hello students, welcome to Sri Siddheshwar Women's College of Engineering Solapur. We are dealing with unit of functions of complex variable differential calculus part. From this unit, now we are going to discuss a very special transformation, that is bilinear transformation, and also we are going to solve some examples where we can use the standard transformations and this bilinear transformation. So let us first solve the examples where we can use the standard transformations. First example, under the transformation w equal to I minus iz upon 1 plus z, find the map of the circle mod z equal to 1. So this is the transformation given to you. This is not actually the standard transformation at present, and here we are given a curve in z plane, which is a circle denoted by the equation mod z equal to 1. That is a circle with center at origin and radius 1 unit. Now we have to find image of this circle in z plane under this transformation in w plane. So let us check what will be the image. The equation of the circle in the z plane is mod z equal to 1. This is the given part. You are given w in terms of z in the example itself. Now we have to write z in terms of w with proper multiplication and arrangements of the letters, arrangement of the terms, so that we can have z in terms of w. So here we get z equal to I minus w upon I plus w. Now we know that z equal to x plus iy and w equal to u plus iv. So we have to use z in terms of xy and w in terms of uv in this result of z, so that we can find the real and imaginary parts in terms of u and v. So on solving this term in terms of u and v with proper multiplication by the complex conjugate of this simplified denominator, we get x equal to 1 minus u square minus v square upon u square plus 1 plus 2v plus v square, and y equal to 2u upon u square plus 1 plus 2v plus v square. So now we are having x and y. So now we can use the given condition, that is mod z equal to 1. We know that mod z means mod of x plus iy equal to 1, which is given by square root of x square plus y square equal to 1, but squaring on both the sides we get x square plus y square equal to 1 again. So substitute x in terms of uv and y in terms of uv in this result, and on solving you will get an equation in terms of u and v, which will be the image or the mapping of the circle mod z equal to 1 in z plane into w plane. So on solution, on solving all these steps, we get this simplified result, and from this we get v equal to 0, that is real axis of w plane as a image of the circle mod z equal to 1 in z plane. So in this way you can find the mapping of a region in z plane under the transformation w equal to some function of z in w plane. Let us move to the one more example. Here you are given vertices of a triangle in z plane, and transformation is given w equal to 3z plus 4 minus 2i. This is nothing but w equal to 3z plus c, we can say, with c equal to 4 minus 2i. Also we can write this as w equal to c1z plus c. So this is nothing but first w equal to 3z and then added the complex constant. So we can say that here first the rotation and magnification is done and then translation is done. Okay, so now we have to find image of the this triangle in Z plane under this transformation in W plane. So obviously, since rotation and magnification is done, means there is no change in the original shape of the region. So surely you will get a triangle in W plane. But because of magnification, the size of the triangle will increase or decrease. And due to translation by the factor 4 minus 2i, the position of the original triangle will get shifted to some other point. So now it is sure that under this transformation you will get again a triangle which is magnified. So in this way also you can solve such type of examples. Here vertices in the Z plane are given in first column. So these are the 3 vertices written in first column. Under this transformation you have to find their images. So just put Z equal to I, Z equal to 1 plus I and Z equal to 1 minus I to get their images under this transformation. You will get here 4 plus I, 7 plus I and 7 minus 5i. So the vertices will be 4, 1, 7, 1 and 7 minus 5 in the W plane. So for the triangle in the Z plane under this transformation, you will get a triangle in which is rotated through some angle and also which is magnified. So this is a case of first rotation and then transformation. So let us see one more example. Here the circle mod z equal to 2 is the original region in Z plane and the transformation is Z plus 3 plus 2i. This is mere case of Z plus C, that is simply translation. So here translation factor is 3 plus 2i. So whatever is the original figure, it will remain as it is. Its shape and size will remain as it is and it will just get shifted to the new position. So this is the example of standard transformation, that is translation. Z equal to x plus iy, w equal to u plus iv. With this z and w and under this transformation we get x plus iy is equal to u minus 3 plus I into v minus 2. Equating real and imaginary parts on both the sides, we get x equal to u minus 3 and y equal to v minus 2. Now use the given region equation, that is circle mod z equal to 2. Mod z equal to 2 means mod x plus iy equal to 2. That is mod u minus 3 plus iv minus 2 equal to 2. You can directly write x square plus y square equal to 4. That is u minus 3 bracket square plus v minus 2 bracket square equal to 4. So this is nothing but the equation of a circle with center at point 32 and radius of 2 units in W plane. So here it is proved that under the translation transformation, the circle in Z plane is again a circle in W plane. The radius of both the circles is same. So there is no change in the size of the circle, that is there is no magnification, only the center is shifted to the point 32. Originally the center is at point O, that is at origin 0 0. Now it is shifted to the point 32. So under translation, the original shape and size of the region or the figure remains same. There is only the change of position. One more example from this topic. Show that map of the real axis of Z plane. Real axis of Z plane means x axis. Its equation is y equal to 0. Now we have to find map of this x axis of Z plane in the W plane under this transformation w equal to 1 upon z plus I. So here first translation is done, that is z plus I, and then its inversion is made. So this is the case of first translation and then inversion. So let us see the resultant image. Again the procedure, the first part is same, z equal to x plus iy, w equal to u plus iv. We have to write z in terms of w. So with this some operations we get z in terms of w, and then you have to replace z by x plus iy and w by u plus iv. Then equating real and imaginary parts, we get x equal to u upon u square plus v square, and y equal to minus of, it should be minus of v plus u square plus v square upon u square plus v square. See, this is minus of, this is having minus I, so y should be negative. Now we have to use the given equation. It is nothing but the real axis, and its equation is y equal to 0. So we have to equate this part with negative sign equal to 0. Finally you will get this term as 0 only, minus 1 will get removed. So solving this, you will get numerator is 0. This is nothing but the u minus 0 square plus v plus 1 by 2 square equal to 1 by 4. So here again you are getting a circle with center at 0 minus 1 by 2 point, and its radius is 1 by 2 units. So the real axis of z plane is mapped onto a circle in w plane under this transformation, which is nothing but first translation and then inversion. So in this case real axis is mapped onto a circle. So in this way we can solve examples where you are given some region in z plane and you are given transformation w equal to some function of z. So now all this is about the transformation or mapping in general. Now we will discuss a particular type of transformation, that is bilinear transformation. Let us see its definition first. The transformation w equal to az plus b upon cz plus d, where a, b, c and d are the complex constants and ad minus bc is not equal to 0, then this transformation w is called bilinear transformation. Here the condition ad minus bc not equal to 0 means the derivative of w with respect to z is not equal to 0, and hence the given transformation, which is a bilinear transformation, is also a conformal mapping or conformal transformation. So remember that a bilinear transformation is also a conformal transformation. Now here w is expressed in terms of z. You can write z in terms of w, and then we get z equal to minus dw plus b upon cw minus a. This is also a bilinear transformation. If ad minus bc is not equal to 0, this derivative is not equal to 0. But if ad minus bc is equal to 0, f dash of z or dw of z, dw by dz will be 0, and the point will be called a critical point. So all this is about the bilinear transformation. Now we will see two examples where we are going to apply this concept of bilinear transformation. Here the points z equal to 1 minus I minus 1 from z plane are given, and they are mapped onto the points w equal to I 0 minus I in w plane. We have to find the transformation w in terms of z. So the procedure is, first consider the given points in z plane as z1, z2, z3. We require 4 points actually, so we will consider the fourth point z4 as some general point z. The same procedure we have to do in W plane. So consider the given 3 points as W1, W2, W3 and one more point W4 as a general point W. Since the cross ratio unchanged under the bilinear transformation, we can write Z1 minus Z2 into Z3 minus Z4 divided by Z1 minus Z4 into Z3 minus Z2 equal to W1 minus W2 into W3 minus W4 divided by W1 minus W4 into W3 minus W2. Now we will substitute all these Z1 to Z4 points and W1 to W4 points in this ratio, and simplifying we will get this is LHS. We get this LHS and this simplified RHS. Now cross multiplying we get this step. Simplification gives us W equal to Iz minus 1 upon Iz plus 1. So this is W, the transformation under which these points are mapped onto these points in W plane. Here multiplying numerator and denominator of RHS by I, we get this result. So finally the answer is W equal to Z plus I upon Z minus I is the required transformation under which these 3 points in Z plane are mapped onto these 3 points on W plane. So this is a bilinear transformation. Now we will see one more example. Here you are given 3 points in Z plane, 1, I and minus 1, and 3 points in W plane as 0, 1 and infinity. This is a special example as it is having infinity in W plane. So if this is the case, the procedure to solve such type of examples to find the bilinear transformation W is different one. So be careful while solving such type of examples. Let us see the solution. The first part is very same. Consider the given points as Z1, Z2, Z3 and one more point as Z, which is your Z4. 3 points from the W plane as W1, W2, W3 and general point W4 equal to W. The cross ratio remain unchanged under the bilinear transformation, so we can write this ratio. Now see here, the point W3 is infinity. So the ratio of the brackets containing this point W3, you have to consider this as 1. So with this ratio consideration as 1, we can write this ratio as Z1 minus Z2 into Z3 minus Z4 upon Z1 minus Z4 into Z3 minus Z2 as W1 minus W2 upon W1 minus W4. You have to remember this property, that is, or you can say this important thing. If there is a point Z1 which is infinity, then you have to write the ratio of the terms or the brackets containing Z1 as 1. So remember this one. If there one of the points given either in Z plane or W plane as infinity, you have to apply this property of bilinear transformation. And now you substituting the given points in this simplified ratio and simplifying, you will get W in terms of Z as W equal to I into 1 minus Z upon 1 plus Z. So this is the bilinear transformation required for the given 3 points in the Z plane which are mapped onto the new 3 points in W plane. So in this way you can find a bilinear transformation. This is very important as far as university exam is concerned. There will be surely one question based on this topic of bilinear transformation. So try to solve many more examples of such type and be confident to solve the examples of bilinear transformation. Thank you for listening patiently. Have a nice day.